Bienvenidos, Ushamdi, and welcome CMIT 454, sections 6380 and 6382 to the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the CCNA Security version 2.0 course from Cisco Networking Academy, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer activity 4.1.3.4, where we're going to be taking our first look at IPv6 ACLs. Now, in a lot of cases, learners will think immediately that IPv6 ACLs are going to be exponentially more difficult than dealing with IPv4 ACLs. And we're going to do a lot of comparing and contrasting because there are some significant differences, but then again, there are also some similarities. But with respect to the level of difficulty with IPv6 ACLs, I actually find working with IPv6 ACLs to be much easier than working with IPv4 ACLs. And I think you might agree after we wrap up this video, because one of the major points of concern for learners new to ACLs is always the wildcard masking and confusing that with the subnet masking. And the great thing is with IPv6 ACLs, it is literally the prefix and the prefix length. There are no wildcard masks used at all when working with IPv6 ACLs. And we'll also talk about the fact that there are no numbered ACLs when dealing with IPv6 ACLs. So they've really streamlined, in a sense, the way that the ACL is created. There's really kind of only a single way to go about creating an IPv6 ACL. And that's a significant advantage because we're no longer thinking, is it going to be a standard ACL? Is it going to be an extended ACL? Am I placing it as close to the source, as close to the destination? You know, is it going to be named? Is it going to be numbered? How am I going to, approach that? So a lot of that confusion and ambiguity has been removed. So let's jump into the activity and take a look here and see what we've got. Again, it's a pretty straightforward activity. They do provide us with some of the information that's going to be needed here for us to be successful. So logs indicate that a computer on the 2001 DB8:1:11:0/64, and that's going to be this network here, is repeatedly refreshing a web page. It's causing a denial of service attack against server 3 over here. Until the client can be identified and cleaned, we must block HTTP and HTTP access to that network with an access list. And so when we look at this, right, remember the best analogy that I can give you is think of IPv6 ACLs as being like extended ACLs, because there is no source-based IPv6 ACL. In other words, there is no quote-unquote, standard IPv6 ACL where we can only filter on the source like we can with the standard IPv4 ACLs. With IPv6, there's no way to do that, right? So it's more like an extended ACL than anything else. So let's go ahead and dive in here, and they actually provide us with some information. So let's get on to router 1 here, and we're going to give ourselves a little more room with which to work. And we'll come over to the CLI, and so we're in user exec mode here. So the enable command is going to get us into privilege exec mode. So the first thing we're going to do is we're going to configure an ACL named block HTTP on router 1 with the following statement. So let's get into global config with the configure terminal command. And we're going to say IPv6, right? And they don't give us this information here. So we're going to say IPv6, and if I do a question mark, you can see we have access list, and we do another question mark, you can see that we have to name it, right? So this is what I was talking about. There is no option for me to say, oh yeah, this will be IPv6 access list 99. Although, let me see if we can do a number. I don't think it's going to, it's not going to take it as a name. So the name must begin with a letter, cannot begin with a number. So we can't say access list 99 or 1399, right? There are no options here to do a numbered ACL, and that's what I was talking about is, again, it's very streamlined in that sense. So there's no ambiguity. Is it a name? Is it a number? No. With IPv6 ACLs, it must be a named ACL. So our ACL is going to be block underscore HTTP. And then as you can see, we're going to go into the config IPv6 ACL sub configuration mode. Now, what can we do from here? So I can do default, deny, exit, no, permit, and remark, right? So I could put a remark in here saying, you know, per management blocking HTTP and HTTP access. And that would be something that would be legitimate that we could put in here as a comment. But let's go ahead and take care of, and again, it's the same syntax and everything, right? So we're going to say deny TCP, and it's going to be any host. So we're basically saying we're denying TCP from anywhere going to, and this is the same ordering as it was when we worked with IPv4 ACLs. And the addresses, I'm squinting here, 2001:db8:1:30. And hold on one second. That is, I don't believe that's correct. Oh, going to, sorry, yeah, that's right. Okay, :1:30, :30, and then is that it, right? Or are we going to say, because right now, if I was to hit enter, we would literally be blocking all traffic that's TCP based. So all SSH, all Telnet, all FTP, all HTTP, all HTTPS, so anything that's TCP based, if I hit enter right now, that is what we would be denying. But remember, that is not what we want to do. So we want to say equal to what? So what port number is this TCP traffic going to be traveling on? And we know that it's going to be www, as we can see up there. Now, the next line is actually probably the easiest one. We would up arrow, come back over www, and say 443 for HTTPS, because again, we're denying HTTP and HTTPS traffic from anywhere, right, going to our server. And the server address, as you can see here, is that 3030, right? And you'll notice we're blocking on the global unicast IPv6 address. We're not blocking on the link local. And we wouldn't block the link local because remember, that link local address is good between 2 points on any given link. We're talking about traffic that could be coming from anywhere, right? Globally routable traffic that's going to be showing up. And so in the IPv6 header, we would be looking for the destination address, right, in this ACL here. And again, with IPv6 ACLs, we are still in the same scenario that we were with IPv4 ACLs. And this is irrespective of whether they were standard or extended. Remember that the ACL is a stateless packet filter. And IPv6 ACLs are no different than IPv4 ACLs. We are still dealing with stateless packet filtering. So every single IPv6 packet is going to be looked at and examined and evaluated to see if it meets any of the criteria that we've outlined here. So remember that. IPv6 ACLs are still stateless, just like IPv4 ACLs. So we'll go ahead and hit enter. So there's our two commands that we need. And now this is another difference, and this is a pretty significant difference. So let me first talk about the similarity. So at the end of every IPv6 ACL, you have that implicit deny any, right? So at the end of the IPv6 ACL, just like at the end of the IPv4 ACL, you have an implicit deny any. Well, there's also two additional lines that are at the end of every IP, and these are implicit, right? So there's a total of 3 now. There's 3 implicit lines. But again, I don't think that adds to the complexity of the IPv6 ACL because we don't see those lines anyway. We just need to remember that they're there. And so let me go ahead and say permit IPv6 and any, and I'm trying to pull up here. It's not going to, IPv6, oh, I'm sorry, CMP, Yeah, and let's say any, I'm looking for, yeah, here we go right here. So at the end of every IPv6 ACL, there's going to be 3 lines, right? The first line, and this will be the first one, it's going to be a permit ICMP any, and it's going to be for neighbor discovery, right? So neighbor discovery, neighbor advertisements, and neighbor discovery, neighbor solicitation. And what exactly is neighbor discovery, neighbor advertisement, and neighbor discovery, neighbor solicitation? Why is it important that at the end of every IPv6 ACL, these lines are implicitly there for me? Well, remember how IPv6 works, right? So there really is no ARP, like address resolution protocol. And it's more based on ICMP v6. And part of that, right, and part of this is sort of the substitution. Think of it as like the replacement for ARP with IPv4 is we use neighbor discovery, neighbor advertisement, and neighbor solicitations. And so if an IPv6 host is trying to, see, hey, who's on the link or who is this on the link, it would send a neighbor solicitation. And then the neighbor can send an advertisement back saying, yeah, that's me. And this is how IPv6 kind of does the layer 2 to layer 3 resolution. Much different than IPv4 with the address resolution protocol, right? Because this uses ICMP v6. As you can see, that's why we had to say, give the permit command. And again, you do not have to type these commands in. So these 3 commands that I'm talking about, again, remember, this is a significant difference between IPv4 ACLs and IPv6 ACLs, is that with IPv6 ACLs, we have a permit ICMP any neighbor discovery, neighbor advertisement, a permit ICMP any neighbor discovery, neighbor solicitation, and then you have the implicit deny. And this is to ensure that you don't break the neighbor advertisements and neighbor solicit, the whole neighbor discovery process, right? And that's why those 3 lines are at the end of every IPv6 ACL, right? They kind of protect us from ourselves. So if we want to make sure, and I think the requirement is allow all other IPv6 traffic to pass, right? So we've denied what we wanted to deny, and now we're just basically going to say permit IPv6 any, right? And this kind of supersedes those 3 implicit lines at the end, because again, this line will come before, and the lines that we explicitly enter in as part of the IPv6 ACL are always evaluated before those implicit 3 lines at the end. So this kind of circumvents allowing that. But in the event that we didn't put that in there, remember that there's going to be, or there will be 3 lines at the end, 2 of them permitting the neighbor discovery, neighbor advertisements, and neighbor discovery, neighbor solicitations, right? And then the final one denying everything else to make sure that we don't break IPv6's neighbor discovery and neighbor acquisition facility. So we'll say permit IPv6 any, and then I think it's going to ask us to apply the ACL. Okay, so here we go. Apply the ACL to the correct interface. So it says apply the ACL on the interface closest to the source of the traffic to be blocked. So again, and I know that you're probably tiring of hearing this, but remember, when we talked about IPv4 ACLs, what did we say? We said that the desired goal and sort of the best practice, if you can achieve it, is with a standard IPv4 ACL that you want to place that as close to the destination as possible. So standard IPv4 ACLs as close to the destination. And when we're talking about extended IPv4 ACLs, we want to place those as close to the source as possible. Again, when we can do that. Given that IPv6 ACLs are most like an extended IPv4 ACL, we want to take the same approach here, right? Because remember, I can filter on source and destination. I can filter on the protocol. So that allows me the flexibility of getting this onto the interface that is as close to the source as possible. And so when we look at this here, and when I mouse over, my VM is just too slow to pull up any information, so we'll have to see what interface this is here on the 2001 DB8:1. But given that information, we're trying to block HTTP traffic coming from this subnet, so we can nip that, right? We can nick it right here and make sure that it's not allowed through. But first, let's say do show IPv6 interface brief. And 2001, it is, it's gig 01. So gigabit Ethernet 01, that's the interface on which we're going to apply this ACL. So let's get under interface gigabit Ethernet 01. Now, this is another difference. And again, not a major difference, but it is a significant difference, because if you're thinking, well, I'm going to type in IPv6 access group, right? And that may be, your initial thought process is, it's IPv4 ACLs, we said IP access group, and then we put the number or the name and then the direction, in or out. Well, with IPv6 ACLs, this is another significant, or I should say it's another minor difference. So we're going to say IPv6. If I do a question mark here, we're going to be looking for traffic filter. And you can see it down there at the end. And it has a nice comment, so it's easy to dig up. It's access control list for packets. So that's what we would say. So instead of saying IP access group, and remember, we'll talk about the VTY lines here in a second, because that is very similar to IPv4. However, here, when we're placing an ACL, an IPv6 ACL, on an interface, we need to make sure we understand that it's not going to be IPv6 access group. And if it's an IPv6 ACL, we certainly wouldn't say IP access group, because IP is representing IPv4. So we're going to say IPv6 traffic filter. And again, do I put the name or the number, right? And you should be able to tell by the inflection in my voice there that I'm trying to get you to start to think in terms of there are no numbered IPv6 ACLs, right? They're all named. And we named our IPv6 ACL block underscore HTTP. And now we have to deal with, just like IPv4, we have to deal with the directionality of it, right? Well, we're placing it on router 1, and we already know that we want to get it as close to the source as possible. So if this is router 1, and this is my source, I can place that right here, so that when these refreshes, right, whoever's sitting here doing the refresh, I'll just put ref, the refresh here, every time those TCP packets show up right here, right, with the SYN or whatever that the case may be for the www or the HTTPS, when it hits that interface, I'm going to get it right away. Now, compare this to putting it here. Why would I not want to put it there? Yeah, exactly. Remember, we said deny from anywhere. So if all I wanted to do was cut these guys off, if I put the ACL here, what happens to everybody on this segment? Yeah, we're saying I don't care where you're coming from, anywhere. So we would punish these guys, right? Or they would end up losing HTTP and HTTPS access to server 3, and that's not what we want. Right, so again, this is a great use case of an IPv6 ACL being placed as close to the source as possible. So let's clear this. And we want it in the inbound direction on that gigabit Ethernet interface. All right, so let's go ahead now and see. It says apply the ACL correctly. Okay, so verify the implementation. So we're going to verify that the ACL is operating as intended, and we're going to conduct the following test. So let's go to PC1. And they want us to pull up the web browser here because, again, PC1 is not going to be impacted by this change, although now we have to type in 2001 DB8:1:30:30. And there we go, Cisco Packet Tracer, server 3, right? Everything seems to work fine. And then, so we're good there, and we could even check out the HTTPS, and let's see if it lets us do that. Hostname unresolved, so I'll say HTTPS, and we'll say 2001 DB8:1:30:30, and we'll hit go, and HTTPS and HTTPS works. Now let's pull PC2 up. And again, remember, this is the bad actor. This is the host that we were trying to deal with and cut off from access to HTTP ://2001 DB8:1:30:30. And did I get that right? 2001 DB8 130. So we say go and take a look at what's happening, right? Nothing's happening because again, excuse me, that traffic is being blocked, right? So that traffic is being blocked. All right, so that looks completely successful. One of the things you may want to do, and again, not having read ahead here, I should have probably gone to PC2, confirmed it worked prior to placing the ACL there. All right, and so we'll do that here. So we're going to configure and apply and verify a second IPv6 ACL. So the logs now indicate that your server is receiving pings from many different IPv6 addresses in a distributed denial of service attack. You must filter ICMP ping requests, right? Now remember, notice here, excuse me, that it's just saying ping requests. Excuse me. I'm getting a sore throat here. All right, and so now where are we going to do this? It says create an access list. Does it tell us? Okay, so it wants it on router 3. So we'll pull router 3 up. We'll bring this down. And let's give ourselves a little more room with which to work. All right, so we're going to go from user exec with the enable command to privilege exec mode, and I'm kind of reading over here, so they give us the name, and let's go configure terminal to get into global config, and we're going to say IPv6 access list, and again, can only have a name, cannot be numbered, and so our name is going to be block_ICMP. And once again, we should probably put a remark in here, you know, hey, we're trying to stop a distributed denial of service attack, so this could be a temporary thing until we can deal with something on a firewall somewhere in our environment. And we're basically going to be denying. So block all ICMP traffic from any, okay, so all ICMP traffic. So not just, you know, an echo reply, echo request, a destination unreachable. So we're doing everything. So it's basically pretty straightforward here, right? So we're denying, what are we denying? Well, it's going to be ICMP, and it's going to be from anywhere and going to anywhere, right? And that's it. And again, it's not asking for us to be specific here and say, you know, echo reply, echo request. It's saying all types of ICMP traffic. And so that is literally the only statement we're going to need to do the denial. But remember, right, and again, I want to stress this with those IPv6 ACLs. So if I hit enter right now, the only traffic that would be allowed is going to be what? Yeah, it's not going to be that no other traffic is allowed. Remember, we've got 3 implicit lines at the end of this, of every IPv6 ACL. And those 3 implicit lines, again, are permit ICMP any neighbor discovery neighbor advertisements, and permit ICMP any neighbor discovery neighbor solicitation, right? So remember, the neighbor advertisements and the neighbor solicitations, the IPv6 ACLs are constructed in such a way that it's going to protect you from turning those off by mistake, unless for whatever reason you were to do a deny everything somewhere here in this ACL, which, you know, you could certainly do, but that is definitely going to deny all traffic. So that's why those 3 lines are at the end. We permit the neighbor advertisements, the neighbor solicitations, and then we have the deny any at the very, very end. So that's why it says here, allow all other IPv6 traffic to pass. So this is where we're going to say permit IPv6 any, right? So pretty straightforward there. So that is the ACL in a nutshell. So now it says apply the ACL to the correct interface. Now, in this case, ICMP traffic can come from any source. So to ensure that the traffic is blocked, regardless of its source or any changes that occur to the network topology, it says apply the ACL closest to the destination, right? So very interesting here that before we did exactly what we would have done with an extended ACL, and that is with an extended IPv4 ACL, and that was we applied it as close to the source of the target as possible, right? We applied it as close to the source. But here, it's saying that obviously we wouldn't put it right here, right? Because then all of this traffic is going to get through. We wouldn't just put it right here because then all of that traffic, or I'm sorry, all of this traffic would get through. You could certainly put it on both, but that's kind of not going to be the most efficient way to do this. But then again, if we're going to put it as close to the destination, and again, the destination is who here? Yeah, the destination is server 3. So this gets us as close to the destination. Now, the only kind of drawback here is if this is the only setup in our network, right, or these are the only hosts in the network, we're allowing all of that traffic to come over here, down into this router, and then finally be blocked, right? And again, this assumes that we're not putting any additional hosts or anything on here, but maybe it's router 2 that's compromised. Maybe it's router 1 that's compromised. Maybe it's all of the routers are compromised, right? Well, it wouldn't make sense to say 3 is compromised because then they would just remove the ACL. But putting it here kind of ensures that anything on this side of the equation will successfully be blocked. And that would include, again, maybe something else gets hooked up here, and then there's another host over here at some point, right, going through this switch. And so that's why we're going to place it here. And again, it does allow that traffic to transit our network before being dropped. However, given the requirements that we've got, this is going to be the best place to make this ACL application. So how do we do that? We're going to go to interface gigabit Ethernet 00. I'm assuming it's 00. Let me see. Do show IPv6 interface brief. And yeah, it is gig 00. So interface gigabit Ethernet 00. And here's what we're going to say. Again, remember, IPv6, is it access group or access class? Yeah, trick question, right? Because it has nothing to do with access here, right? So it's not an access group, it's not an access class when we're talking about IPv6 on an interface. So we say IPv6 traffic filter, we can only name the IPv6 ACLs, and this was, what do we say, block, oops, let's get that right, block underscore ICMP. And which direction? Well, if we're putting it on that gigabit Ethernet 00 interface, would we be blocking it from the perspective of the interface? Are we blocking the traffic coming this way? Or are we trying to prevent the traffic from going out the gig 00 interface to server 3? Yeah, it's unquestionably, we're denying this in the outbound direction. And so that is the direction that we are going to pick for our application here. So we're going to say out, and we're going to hit enter, and that should be our final 10 points, and it is. And so that gets us where we need to be. So now let's see here. We're going to ping from PC1. And so let's close our web browser down. And the ping should fail from both of these. So let's say ping 2001 db8:1:30:30. And we get that destination host unreachable. And let's confirm PC2 also no longer has connectivity here. So ping 2001:db8:1:30:30. And we get the destination host unreachable, right? So again, telling us that an ACL is involved here. Now, what is interesting, and let me see, trace RT, and if I can trace, let's see if this works, 2001 db8:1:30:30. Yeah, so we can, oh, actually this is kind of looping. Yeah, so it's looping, so it's not doing what I thought that it would do. And that may be because of how things are set up here in this activity. So that is IPv6 ACLs. The last thing that we want to talk about, and it's not part of this activity, but it's worth a few seconds of discussion here. So when we say, oops, sorry, line VTY 0 to 15. When I say line VTY 0 to 15, so let's say I want to protect who's able to access the virtual terminal lines, who's able to administer router 3 here remotely. And that's why we go into those virtual terminal lines. And it's here, remember, where do we say, and again, follow with me here, do I say IP access class and then put the access, the IPv4 access list there, or do I just simply say access class? Right, and this was an odd behavior in Packet Tracer, and I'm not sure why it's in here. So the proper way to do this is to say, with IPv4, is to say access class, and then again, as you see right there, you either put your name or your number for the standard ACL, right? And that's how IPv4 deals with it. When we're working with IPv6, what we say is we say IPv6, and again, take a look at that, a single option, IPv6 access class, because we need to differentiate it from the default behavior, which is when you just type access class in, it thinks it's an IPv4 access class, right? So let's take a look at a real Cisco router, and you notice that what we just saw there, the behavior we saw. So if I go into global config and I say line VTY 0 through 15, so the first 15 VTY lines, and I say IP question mark, where is access class here? And it's not anything particular with this release of Cisco IOS. And again, this is a real Cisco IOS. It's a was 1841 router, and even if I come onto a newer a 1941 router here, we're going to see the exact same behavior. And so during the CCNA Routing and Switching Networking 4 course for connecting networks, this came up, and it was an interesting point of conversation as the way Packet Tracer was behaving. So again, when I say line VTY 0 through 15, when I say IP and I do a question mark, again, and this is running, what, 15.5 code. So this is far more recent than Packet Tracer, and even in older versions, there's no option here for access class. So in Packet Tracer, I don't know why, but under the VTY lines, if you say IP and do a question mark, it prompts you with access class. But remember, on real Cisco IOS hardware, that is not an option, right? Again, we would have to say access class, and then we give the standard normal range 1 to 199, or the standard expanded range number 1300 to 20, or I'm sorry, that's just expanded access lists. For the expanded numbers 1300 to 2699, right? Or the word, right, or the name of the ACL. But again, keep that in mind, that with IPv4 ACLs, you do not say under the VTY lines IP. There is no option here in real Cisco IOS. It's just access class. Then you put your name or your number. And it's the same with IPv6, right? When I say IPv6, I have to say access class to differentiate it from the default, which is just IPv4. And then we would put our name in here, block underscore HTTP, and is it in the inbound or outbound direction? And so we would put it in the inbound direction. So just a quick point that you may run into with Packet Tracer, and I want to make sure that it doesn't cause any confusion. And Packet Tracer may deal with this. Packet Tracer may be set up to take, and you can see it doesn't allow you to put a number. You have to put a name here, and so it's kind of interesting, like I said, because with the normal iOS, you do not deal with the application of access lists on the VTY lines in this form or fashion. So be aware of that. All right, well, let's go ahead and do a really brief review, a recap here of the similarities and the differences between IPv4 ACLs and IPv6 ACLs. So the number one thing to remember, and what we just talked about, is there are no numbered IPv6 ACLs, right? So there's no such thing as a numbered IPv6 ACL. We can only use names. The host command is supported, right? So the host keyword, we use that. The host keyword is still there. And so it's like saying /128, right? So it's just when we do that the host keyword with IPv4, it's like we're saying /32. With IPv6, it's like saying /128. And believe me, just putting the host keyword in there is going to save you a lot of typing instead of having to put in all of the zeros if you were to do it like when we do the quad zeros. But again, you don't have to do that, right? That host keyword is available just like it is with IPv4. So there's no wildcard mask, right? Remember that. We never worked with a wildcard mask, and it doesn't exist with IPv6 ACLs. It's only the prefix and the prefix length in that CIDR notation, like a /64, a /56, a /128. There's no way to create a standard like, right? So a standard IPv4 ACL which only filters packets based on the source address. There's no way to do that in IPv6, right? So there is no source-based IPv6 ACL. There are only layer 3, right? We've got the layer 3 information, source and destination, and layer 4. And again, the application, when we go onto an interface, it's IPv6 traffic filter. When we go under the VTY lines, as we just saw, it's going to be IPv6 access class. Okay, and remember, there is no IP access class command in real iOS, or at least the 15x codes that we're looking at. So we got the access class O. And so then finally, to hammer on this one final time before we finally move on from ACLs, and we're going to start dealing, we're now going to ratchet things up a bit, and we're going to move on to Cisco's next iteration, which was the zone-based policy firewall. Remember that ACLs, whether they're IPv4 standard ACLs, whether they're IPv4 extended ACLs, whether they're IPv6 ACLs, they are all stateless. They do not track any state information about the conversations. They don't track idle time. They don't track bytes sent. They're not tracking anything. They are all stateless packet filters that are looking at those packets. One packet, they're evaluating those packets a packet at a time. Every packet that shows up gets evaluated. And then the final significant difference is the end of the IPv6 ACL, where we have 3 implicit lines that will be at the end of every IPv6 ACL. The first one that's going to get evaluated is a permit ICMP, any for neighbor discovery, neighbor advertisement. The second one that's going to get evaluated, it's going to implicitly be there, it's invisible, right, is going to be permit ICMP, any neighbor discovery, neighbor solicitation, and then the very last statement is going to be deny IPv6 any. And so again, that is a significant difference. And remember that the reason that those neighbor discovery messages, those 2 neighbor discovery messages, the neighbor advertisement and the neighbor solicitation, the reason that those are allowed through is because that is how IPv6 deals with the layer 2 to layer 3 resolution, right? And it's the substitution for ARP with IPv4. Remember, at IPv4, the question that ARP is asking is, it's like, hey, I know the IP address, right? So I know the layer 3 information. So I know 192.168.1.1. However, I'm going to ARP out because I don't have your layer 2 MAC address information. I need that forwarding information so that the packet or the frame can be forwarded at layer 2. And with IPv6, neighbor discovery using ICMPv6 accomplishes the exact same thing. All right, well, this wraps up access control lists, and you can see based off the importance and the volume of activities that we had to accomplish here in Packet Tracer, that ACLs play a very, very important role in the CCNA security curriculum. And so definitely do as many little exercises as you can. Make sure you complete all of those drag and drop activities in the course on NetAcad. All right, guys, thanks for watching, and I will talk with you soon.